So this question has two different masses that are in an xy plane, and we want to figure out what the total angular momentum is about the origin. And the origin is a nice little spot right over here. So I need to calculate out my total angular momentum, which is just the angular momentum of 1 plus the angular momentum of 2 for all my masses. And I know that angular momentum is defined as two different values, either I omega or r cross p. I don't know omega. Omega is an angular velocity. All the velocities they gave me are translational velocities. So I think I want to use the second equation. So I'm going to use L is equal to r cross p, which is equal to r cross mv, just substituting in what my momentum is, my linear momentum is. And I need to know that the magnitude of this value is going to be r mv times the sine of the angle between r and v. Well, my r's, one of my r's points straight up. R1 points straight up, and V1 points straight over, and they're at 90 degrees. So that means this angle right here is going to be a value of 90 degrees. The sine of that angle is going to be a value of 1. That makes it nice. Same thing over here. R2 points in this direction. V2 points straight up, and they again have a mutual angle between of 90 degrees. So in both cases, they both reduce to a value of 1 because of the theta being 90 degrees. All right, so let's add up all of our totals. So our total angular momentum is equal to R1 M1 V1 plus R2 M2 V2. Before I get any further here, I put a plus sign down. I don't know if I add these or subtract these, so I want to be very careful that my cross product, this part of this angle thing here, is right. So I'm going to use my right-hand rule and go R cross into V. This points in the positive Z direction. I have X, Y, and Z is going to point out at us. So I have R cross into V gives me upward direction as my value. So this is actually going to be a vector equation because I have a vector. And I have the second one. My second one is R cross into V. It points again in the positive Z hat direction. So I actually get to add these values together, which just substituting in everything means that R1 was 1 meter, M1 was 6 kilograms, and V1 is 2 meters per second. And I'm going to add to that 2 meters times 3 kilograms times 3 meters per second, which gives me a total of 12 plus 2 times 3 times 3, this is 18 kilograms meters squared per second, which is the same as 30 kilogram meters squared per second. So I look at choice D as my correct answer. So just running through everything, I needed to figure out R cross P for each of the individuals, add them together, but being careful that this is a vector equation, so I have to make sure, using my right-hand rule, that I'm actually adding the vectors together in the right direction. So the last thing to note is that the total angular momentum is 30 kilogram meters squared per second in the Z hat direction, the positive Z hat direction. So it actually points out of the page at us.